Hello class, this is lesson 14.2. In this lesson, this is titled Choosing Among Linear, Quadratic, and Exponential Models. So what we're going to be doing in this lesson is we're going to be gathering data and then determining if that data fits a linear model, so like a straight line, a quadratic model, which is a parabola, or an exponential model. We're going to be using Desmos to plot the scatter plots, and it's actually going to be doing all the work for us, but we have to learn how to use Desmos properly to find our solutions. Okay, so let's get started. Really quick, we're going to just cover what a scatter plot is. A scatter plot is a set of data plotted on a coordinate. So in this example, we have scatter plots A, B, C, and D. So when we work with data, we don't know whether the data is a linear model, quadratic model, or exponential model. So what we do is we have to do some statistical analysis, but sometimes we can kind of see what the data produces. So if you look at this data, look at these graphs, which one do you think looks like a linear function? So right here for scatter plot A, do you think a linear model will be appropriate? So if we look at this scatter plot, it does seem likely that we could draw a linear line through these points, and also through these points as well, and even through these points. But what if this is part of something bigger? What if this is part of a quadratic, which is a parabola, which if you imagine a curve going through, or if something is exponential, so something that is steep and drops down really quick, that's what we're going to be looking at. Okay, so to start, we're going to be modeling. So what we're going to be doing is we're going to be given a table. So this table on the left. And we're going to plot these data points on Desmos. And then after we do that, we're going to check to see if they produce a linear, quadratic, or exponential function. So in Desmos, what we need to do is we need to first type in a table, and then we need to type in these equations. Notice that there is no equal sign, that when we type this in Desmos, that we have to use this symbol instead of an equal sign. And for the variables, we have to actually use a subscript. So y1 is equal to mx1 plus b. But I'm going to be giving you guys a link so that you guys don't have to worry about typing these. All you have to worry about is plotting your table and then reading your table. So let's get started. I'm going to switch to Desmos, and I'm going to type this data in Desmos. So when you guys click on the link, this is what you should see. You should see a table, and then you should see these. This is the linear, this is the quadratic, and this is the exponential. So we're going to start here just by typing in the data. So we have 3, 21, 12, 25, 45, 49, 67, 75, and then 90, 119. And then you're going to click on this plus button, which will zoom your graph based off this table. So we're here. Okay. So now let me uncheck these boxes. So these are our data points that we plotted. If we think that these data points form a linear function, let's look at the first one. So notice that this is the best approximate linear function that's given. And what we notice is, let's see, what we're looking for is this value here. So this r squared. What we want is this value to be equal to 1. So the closer that this value is equal to 1, the better the points match that model. So again, if you look at this linear function, there are a few points that are not on the line, but it could be a linear function. Let's uncheck that one and let's check the quadratic function. Now, from the quadratic, this does look like it fits perfectly because most points are on the quadratic parabola. There's some that are a little bit off, but overall, this looks better than the linear one. And if we look at our r squared, that is 0.999, which is really close to 1. But now, what if we look at the exponential graph? So now this one is perfect. Each point is on the line. And if we look at our r squared, that is equal to 1. So you would actually choose the exponential function for these data points. And what's great about Desmos is that they give you the parameters. Now, parameters are the values of the coefficient. So the values of the variables. A is 19.836 and B is 1.0201. So if you were to want to create an equation, it would be y is equal to let's just round that to 19.8 times 1.02 to the x power. So we were given the values of the variables from this model. And that's all we're doing in this lesson. So we're just going to keep practicing with tables. So let me go back to okay, and if you look down below, this is what we just did. So they actually just took clips of each of those things. And then we're going to actually try a problem, or try a few problems. So, number one, they tell you it's exponential, but what we're going to do is just test that out again. So, again, with the link that I'm going to be providing you, we're just going to type in the data. So for number one, we have 1.2, 1.7, 2.8, 7.0, 3.4, 11.8, 5.9, and 105.1. And then we have 7.5 and 426.3. And let's zoom in this graph, and this is what we get. So by looking at the graphs, let's start with the linear one. So this one does not look like it's linear at all because the points are not on the line. If we look at the quadratic, maybe, but the points are not on the parabola. And if we look at the exponential, that fits perfectly. Now, if you look at the r squared values, for the linear one, it's 0.75. For the quadratic, it's 0.95. And notice that for the exponential, it's exactly 1. So because it's exactly 1, that tells us this is the correct model. So this is an exponential model. Okay, and then let's try one more. So now for the next table, we have 2363. We have 3487. 59,141. 71,167. And 94,216. And let's fit this. So we have this. Okay, if we look at our R-squared values, let's start with the linear. Now, all points fit in a linear line. So this one is most likely going to be linear. If we look at our parabola, we do notice that all points are on the parabola, but honestly it looks more like a linear. And if we look at the exponential, that one doesn't work as well. So for this one, I would say it is the linear. Okay, now let's do the next problem. So for the next one, we have 3.4, 63.4, 8.1, 45.5, 12.9, 73.8, 15.2, 87.4, 17.3, and 99.8. And let's fit that to the graph. So by looking at these, this R-squared is 0.65, this one is 0.93, and this one is 0.72. So this one is the closest one, and I would say this would be a quadratic. And then that's how we're going to be doing the rest of these problems. So let me kind of go back to the So we said B was linear, C was quadratic, and then I want you guys to try D with the link that is attached to the video for Desmos. You're gonna be doing that. And then for problem number 2, again, we have data here, and I want you guys to plug in this data to the Desmos and compare it to what they have already. So this person actually used a graphing calculator, which is another way of graphing, and this person is saying that the regression model is a quadratic, but what we want to do is just check to see if it could either be linear or exponential, again by typing in this data on Desmos. So when we're modeling something, when we are modeling data, we could apply this to any kind of word problem. For example 1, this is an example about the length of a femur and the height of someone. And we have the data here. We're going to be using these same linear, quadratic, exponential models on Desmos, and then if you plot them on the graph, so again, let's pretend that you plotted them, you notice that this fits a linear model, And with the linear model, they actually tell you what m is, what the slope is, and what the y-intercept is. And then you could use that to create your own model, your own equation. And that's the goal for this. Using the parameters that are given in Desmos, you're going to write your linear model as an equation. And in this problem, that's what we want to do here. So we're going to be typing all of this in. Now they're kind of telling us this is going to be an exponential model, so we're going to be looking at the exponential parameters. What is a and what is b after we type in all of these? And then what is the equation? What is r squared? And then what is more accurate? Is it more accurate to say this is a linear or exponential? And then answer the question below here. Yeah, and that's pretty much how this lesson is. That's the end of this lesson. If we look at the homework, lesson 14.2 homework, what we're going to be given is we're going to be given some graphs, and we're going to be given data, and we're just going to be selecting what is the best appropriate model. So for question 1, determine if an exponential would be an appropriate model for the data shown in the scatter plot. So what they're pretty much asking is, does this look like an exponential? So either yes or no. Does this look like an exponential? Yes or no. And does this look like an exponential? Yes or no. And then for question number 2, this is the table that we're going to create. So your x's are going to be here from 0 all the way to 22. And then these are going to be our y's. So 88 through 292. You're going to make that scatter plot on Desmos. And then you're going to find out the parameters for the exponential model. So what is a and what is b? And then using that model, answer the question below. And then the checkpoint, same thing. So we have scatter plots, and they're asking us which one represents an exponential model. And for number 2, same thing. All right, guys, have a good day.